Hi, friends. My name is Jared. I am with Sentek, Galcon Sentek Irrigation, Soil Moisture Monitoring, and Irrigation Controls. And I want to make some videos, and I hope you have some patience with me as we walk through this journey together. We have lots of new friends that are joining us currently. Jumping on the Sentek platform and need to learn about IrriMAX in a really big hurry. I do individual training. Feel free to reach out to me. My cell phone number is 615-981-2151. My email address is jshivers at Sentek, Sentek, USA.com. And I'm more than happy to do individual training. We will put these all together and do webinars. That's the plan. But for right now, I'm going to release these onesie twosies, and please, send some feedback. Let me know what you like. Let me know what you hate. Particularly the word friends. Maybe I'm going to use that too much. I don't know. I don't know how to refer to you guys, but I like each and every one of you. I'm rooting for you, and I want to see you succeed. So let's go with friends. Thanks so much. So let's get started talking about stacked graphs. This will be probably the first graph that you create if you log into your logger page. So from your home page, that's my home page, which is a bit more complicated than what you're going to see. You can jump into your loggers and you can see your loggers in here, or you can come out, you can right click, you can create a new graph, and generally, let's just go ahead and do that. I'm going to create a new graph, 7F2, because I've been speaking with Mr. Kevin quite a bit. And let's make this a stacked graph. And we're going to leave all of our sensors active because we don't know where our plant is growing at this point, and we're going to create that graph. Now, this is the graph that we see. What we notice first is we have numbers along the left-hand side that represent a theoretical how much moisture would be in a cubic foot if you could milk all the moisture out of that cubic foot. Could you truly get 3/4 of an inch out of the top cubic foot of soil? We're going to talk about that. So, where is sensor number one? Sensor number one with the black line is at 2 inches. Sensor number two, right down here, is at 5.9 inches. So that's where you are in the soil horizons and the soil profile. Sensor number three is at 9.8 inches. And what you have is a sphere of influence, is what we call it. So basically, this is an electronic probe, an electronic sensor. Think about a sonar on a submarine. I think most people can get that concept, where you ping and the radio waves go out and then they bounce off of something and they come back and then you can locate stuff. What we are locating is how much water is in the soil, in cubic feet and those type of things. So we know this is what IrriMAX and Sentek probe is guesstimating is in our soil. This is where we are saying it is located. Now, there are obvious limitations to this, okay? Let's jump into what some of the limitations are. The first thing is that let's talk about calibration, okay? So we have a lot of calibrations. You're more than welcome to play with those. If you jump over here into edit, you can do a data adjustment and you can recalibrate each sensor into a different soil type that you feel like is closer to your soil. Now, the upside and the downside, I tell everyone with IrriMAX, is we have all the power in the world, is the upside, and we have all the power in the world, that is also the downside. With great power comes great responsibility, and you can get your calibration really wild playing with some of these things. I geek out on this. So creating a new graph and screwing around with calibrations is fun to me. Don't judge, but I enjoy it. So more than welcome to do that for sure. We also have temperature compensations, specifically on your top sensor, the heat. So we do a good bit of business worldwide, deserts, wild situations. Arizona is one of them, and the heat in Arizona on that soil type creates such a fluctuation in sensor one that a lot of times we have to adjust our reference temperatures and those type of things. Once again, you got all the power in the world, but you got all the power in the world. Use with caution. Um, yeah, so that's a bit on that. That's a bit on calibration. What I like to show people is that's the kind of the downside to calibration. But the interesting thing that we have established, and we've been at this for 40 years. So if you're asking a question, it's probably been asked before. I'm fairly new myself, so I may not have the answer, but I definitely can go to our team and ask the questions and those type of things. You see this right down here is the calibration equation. This is the other calibration equation. Just realize this one is not really close to that one very much as far as math people. Um, don't quote me on a lot of that because I don't understand these per se. But what I do understand is the drop in soil moisture lines up with the drop in soil moisture. Now, if you get really specific, you may see a bit more of a drop here, a bit more of a rise here, a bit less there, a bit less here. But the curvature of this line, the decrease in soil moisture, the increase in soil moisture, is at the same curvature even though it's not calibrated. So even though most of our calibrations coincide with Southern Hemisphere, New Zealand, Australia, those type of environments, the curvature and the moisture is it is fairly accurate. It is not precise, but it is accurate. You will see a curve, and that curve is real world. Okay. The other thing to know is the soil triangle. And everybody wants to talk about what is the field capacity if you are right there. Like if you're if you're way down here in this exact corner of clay loam, what's your field capacity and how different is field capacity from here versus here? If you want to frustrate a soils person, just go ask them that question. What's the difference in field capacity from here to here to here to here? That is all inside of clay loam. But there is a significant deviation, and it is highly contested what the field capacity would be given the rock that the molecules of the rock that made that clay, giving it the ionic charge, and you're talking adsorption versus absorption. Absorption meaning how much water can flow into the soil profile. Adsorption is how much water is going to cling to this clay particle, and that clay particle you can beat it to death and it's never going to let go of that moisture molecule because it has a positive charge and it's magnetized, for lack of a better term. It's going to suck water to it and you can't get it to let go. So it's like a 2-year-old with a lollipop. That, I mean, you might be able to pry it away, but oh man, you're going to pay for it. So that's adsorption versus absorption. um, and that is why we will always we you'll never get all the moisture out of a soil profile. So when we start having these conversations about, is this number of 1.4 inches, if I could dig up this cubic foot of dirt, could I actually milk 1.4 inches of moisture out of that cubic foot of dirt? No, you're never going to get all that moisture. Does all that moisture exist? It depends on where the calibration is versus the curve. I'm trying to get some funding and some money to go to Arizona and spend a lot of my winter this winter digging in the desert and calibrating, because they have some really cool soil types relevant to the majority of this hemisphere, to the majority of the North American soil types. And don't get me started on a lot of that. But anyway, we are continuing to improve those uh, those equations that I showed you earlier are hard fought to get there. It takes blood, sweat, tears, and digging in the dirt to get there. But what we want to see here is, this is a stacked graph. This is, this is what the moisture is in the top cubic foot of soil. It is relevant to what you actually see. And so that is what's going on. The next thing we're going to talk about is why this graph moves the way it moves, and how to start reading the graph, how to use some of the really cool tools. So I hope this was informative. Please comment on, ask me questions, email me, yell at me and tell me I wasted your time. I don't care. Let me know what's going on. I want to be here. I want to be an asset to you. I want to help. So yeah, Jared Shivers, Sentek USA. Thanks so much for watching, and I will produce another video very soon. Thanks.